Hello everyone and welcome once again. In this section we are going to start with network services. So let's have a quick look at learning objective of this section. First of all, we will be starting with the overview of GCP network services, and after that we will move to network tiers. We'll see how many types of network tiers are there and what are their uses. Then we will move to cloud load balancing. After that, we will have a look at the VCP, that is virtual private cloud, and we'll also look at the hybrid connectivity. And after that, we'll have a demo session on configuring the load balancers. And finally, we'll move to the use case of network services. So let's get started with the overview of GCP network services. So the network services are one of the key building blocks of cloud. That can be any cloud, either Azure or AWS. It's the key building block of any of the cloud provider. Okay. So the GCP leverages the Google's global network for connectivity. What does that mean? So Google has a very expensive infrastructure, and on that infra, there are Google's own applications like Gmail, Google Search, or YouTube, and these are some of the best performing applications in the world. So the customers who are going for the GCP network services, they will be using the same network connectivity that Google services are using for their purpose, and that's one of the key advantages of using the GCP network services. Okay, now the customers can choose between standard and premium tiers. So when you are starting any network services, you have the option to choose between the standard and the premium tier. By default, if you don't choose any option, the premium tier will be selected and you have the option to change to a standard tier as well. Okay. Now the load balancers route the traffic evenly to multiple endpoints. So as the name suggests, load balancer that will be balancing the load, that is the amount of traffic that is coming. It will be distributing the traffic to different instances of the application. Okay. The next is the virtual private cloud VPC that offers private and hybrid networking. So in the public cloud, there will be some areas where you can launch your private instance, and that will be called virtual private cloud, that will be used for a security purpose and hybrid networking. Customers can extend their data center through hybrid connectivity. So further in this video, we will look at all these points in details. Okay. So now let's go one more step ahead and learn about the network service tiers. The network service tier provides a choice of traffic optimization. So what is traffic optimization? That means that you can customize the traffic based on the network services that you choose, right? What kind of performance you need from your network service, that you can choose by using this GCP network services. Okay. So there are two type of service tiers. One is the premium and other is the standard tier. Okay. So the standard tier will deliver traffic via Google's premium backbone. So this premium backbone, what does that mean? We discussed earlier. Google has a very expensive infrastructure where some of the Google own services like Google Search, Gmail, or YouTube are running. Okay. So when you select the premium tier, it means that you are going to use the same kind of network services that these premium applications of Google are using. Okay. And the standard tier uses regular connectivity based on ISP or Internet Service Provider networks or the third party networks. So the standard tier cannot match the performance that is delivered by the premium tier. So that's why this is a paid service, and when you choose the standard tier, it's a free. Okay. And GCP uses the premium tier as a default option that we discussed already. Whenever you launch a network service for your application, the premium tier will be selected as a default option, and you have the option to make it to standard tier. Based on the requirement that you have, you can optimize the traffic. Okay. Now let's try to understand the Google Cloud load balancing. So it is one of the most common services that are used by the developers and the DevOps team. Okay. So the load balancer distributes the traffic across multiple GC VMs in a single or multi-region. Means that When you launch a load balancer and attach it to your VM, it will balance the load in a single region or a local region. And if your application is hosted globally as well or in the multi-region, it can balance the load in multi-region as well. For example, if you launch up an application that has its instances in US and Europe, so when you attach a load balancer, it can route the traffic equally to US as well as Europe. Now there are two type of load balancers. One is the HTTPS load balancer and the other is network load balancer. HTTPS load balancer is a global load balancer. What does that mean? That when you have application that is hosted in multiple regions or multiple zones, that time you can go for HTTPS load balancers. So you can say that it's used for balancing the load between multi-regions or multi-zones or global load balancing. And the other is the network load balancer that is used for regional TCP and UDP traffics. When you have your VM instances that are launched only in one region, let's say you have in Asia Mumbai, that time you can use the network load balancer that will balance the load between different instances that you have launched in the Mumbai region, that is single region. Okay. Now apart from being the global and the local, the load balancers can be internal or external as well. What does that mean? We'll see that by a architectural diagram. So in this diagram here, you see that there are mobile device or web applications and the users are coming from different regions. Okay, so it's US and Asia, right? So first of all, whenever any user will send the request, it will be intercepted by the external load balancer. Okay, so in this case, this is multi-region user. The user is from US, so the external load balancer will check the where the user is coming from, and in this case, the user is coming from the US, so it will route the traffic to the nearest region that is hosted. So in this case, you can see that we have US Central 1A, US Central 1B, and Asia East 1A. And the user from Singapore, that is Asia region, when it is intercepted by this external load balancer, the traffic will be routed to the Asia region. And in this case, it will be routed to the US Central region, right? So depending on the where the user is coming from, the external load balancers will distribute the load. Now, once the traffic is at the web tier, it has to talk to the database via some app servers, right? And these app servers are not one. There can be many app servers, right? So which server you want to hit, whether you want to go to this server, whether you want to go to this server. So there is a requirement of load balancing here as well. And that request coming from the web tier is intercepted at the internal load balancer level and it balances the load equally to all these app servers in this region. Similarly, in the San Francisco region, it will be balancing the load all the app servers that are available in this Asia region, right? So you can use the combination of this internal and the external load balancing to achieve the scalability and better performance. And you can understand this from this diagram very well. All right. So now let's start with virtual private cloud or VPC. As you know that the applications deployed in the cloud demand high security and isolation, right? And that's where this virtual private cloud comes into picture. So as the name suggests, VPC is a software defined network providing private networking to VMs. So when you deploy an application, it's possible for us to create a private space within the public cloud and deploy the application within that area. And that area we basically refer it as virtual private cloud. VPC network is a global resource with regional subnets. So if you are familiar with the networking concept, you must know that it is possible to create multiple subnets as a part of VPC. So VPC is a global resource, which means you can create VPC that is visible from any of the region that you have in the GCP. And beyond that, you can create a subnet per region, which is going to be attached to same VPC. And that gives you a lots of flexibility, power, and ease of use. Each VPC is regionally isolated from each other, and this is one of the core requirement of virtual private cloud. This means that one VPC cannot see other resource deployed in other VPC because each VPC is running on its own isolated environment. Okay, so if you are creating multiple VPCs, you need to explicitly allow communication between these VPCs using the firewall rules. The firewall rules allow or restrict traffic within the subnets. So it is quite common for customers to create a public subnet and multiple private subnets and keep sensitive resources within the private subnets. And the private subnets are never exposed to the outside world. Resources within VPC communicate via IPv4 address, and there is a DNS service within VPC named resolution. VPC networks can be connected to other VPC networks through VPC peering. So if you are running multiple VPCs and want to share resources with other VPCs, then you need to create a VPC peer. A VPC network are essential building block for configuring the hybrid networks, and this is possible when you use the Cloud VPN or the Cloud Interconnect. So VPC is the basic requirement for enabling hybrid cloud connectivity between your on-prem data center and GCP public cloud. So now let's understand what is this hybrid connectivity. So there are some legacy applications which are your on-prem applications, which are not on the cloud, which is on your local. And there are some applications which you are using to deploy it on the cloud. So hybrid connectivity means that your cloud applications, when it want to use the resources that are already there on the on-prem, that time you can use the hybrid connectivity services. So Google Cloud offers multiple mechanisms to extend your on-prem data center to public cloud. And that's what we call it as a hybrid connectivity, right? So hybrid connectivity extends local data center to GCP. So this is your local data center and you want to extend it to GCP. Okay, so you are moving these resources which are on-prem to the cloud environment. So how do you achieve the hybrid connectivity? So there are three GCP services that enable the hybrid connectivity, and these are Cloud Interconnect, Cloud VPN, and peering. So the Cloud Interconnect extends on-premise network to GCP via dedicated or partner interconnect. What does that mean? That when you are considering your local data center to move to the cloud, you can choose between the Google's own network that is spread across the globe, or you can go for one of the partner that Google designates for configuring the interconnectivity. All right. So if you don't want to spend a lot on the cloud interconnect and you want to achieve the secure connectivity, then you can go for Cloud VPN, which connects the on-premise environment to GCP securely over public internet. So it is very economical and very much affordable to extend your data center to cloud. Then there is a peering which gives you direct access to the Google Cloud resources with the reduced internet egress fee. And this egress fee is the bandwidth that you are charged for outbound connectivity. Alright, so you can choose any of these services depending on your requirement and budget. Now let's move to the demo part where we will be creating a load balancer and we will be routing the traffic to our web servers using that load balancer. So first of all, we need to create a web server on which we want to distribute the load, and then after that we will create the load balancer. For creating the web server, this time we will be using the instance template. Go to the search and type the instance template for compute engine, where we will be creating a template. Basically, this instance template will be having the blueprint of how our server will look like or how we are customizing the server, right? So let's go and create an instance template first. Okay, so I will name this instance template as web template. Okay, web template, and I will select the series as N1, that is first generation. You can see that the charges here will change according to whatever you select in your configuration. So I will be using the F1 micro. You can see the charge is reduced to $4.88, and I will leave the machine type or boot disk as devres. So default one I will keep it. I will not change anything in this one, and I will allow the default access, and I will also take this allow HTTP traffic. Okay, and in the management console we will be giving up a script here, and the script will be this one: git update install Apache 2. So this will basically install Apache 2 on our server, and we will create a file with the index HTML, and in that file we will be just displaying hello from hostname. So this hostname will be variable here, and we will be using this script in this startup scripts. So whenever I am creating any instance using this template, it will run this script, and it will install Apache 2 and default HTML page on that particular server, right? And then we will leave everything as it is and go and create. Now our web template is created, or the instance template is created, and now we will go and create the instance group. You can see here instance groups. So click on this instance group and create. This will basically launch up your instances. I will keep it stateless, and I will name this instance group as web server. Okay, and I will use this instance template whatever we created just now. Now this is a single zone. I will keep it multiple zone, and I will use the nearest zone which is available to me. I will keep it Asia South 2, and the zones I will use all the three zones. Okay, now the minimum number of instances you can select here. Auto scaling if you want. I don't want auto scaling, so I will turn it off. And the minimum number of instances that I want for my web server is 2. So there will be 2 instances that will be launched. So I will keep the maximum number of instances as 2 because I don't want to create more instance. And after that, come down here. For auto healing, we will be creating a health check, and there is already a health check created here, WebHC. Let me create a new one, create health check, and I will name it as HC Web 2. Okay, protocol I will be keeping at HTTP, port is 80, and the path is root, and check interval, that is health check interval is 5, the timeout is 5, health check threshold is 2, and the unhealthy threshold is should be more than this healthy threshold. Let me keep it 5. Okay, so this health check basically what it does is that whenever you create an instance, every 5 seconds this health check will be checking out the instance if it is in healthy condition or not. So I will save it. So because the health check will replace unhealthy instance, you may want to increase the check interval to at least 10 seconds. We should not get this error. The health check interval as 10 seconds. Save. And the initial delay, so initial delay is basically for the first time when your instance is launched, how much delay you want for the first health check. 300 is a lot more time, so I will keep it 60 seconds, and that's it. I have to select this web template, and the number of instances I want to keep it as 2, right? So I am done with the configuration. Let me go and create. It might take around 2 to 3 minutes for creating the web server. Let me fast forward. So my web servers are created. If I go to the web server, I should see the two instances. Yeah, so there are two instances here. If you go to your VM instances, you should be able to see two instances, the web server name, and there is a unique name that is appended here with each of our web servers, right? Sorry, when we click on this external IP, it will open a web page, hello from web server. Okay, this is the HTML page that we configured, and the other one, you can see this. So both of them are having different host names, so that is visible here, right? Now we have created the instances. It's time for us to create the load balancer and check whether the load balancer is working or not. So we can go to the search and type load balancing. So network services is having this load balancing, right? And create load balancer. So we are going to use this HTTPS load balancing. We discussed TCP load balancing and UDP load balancing, but we are going to use HTTPS load balancing because we have a multi-region instance selected, right? So start configuring, and here you will get the option only between my VMs or from internet to my VMs or serverless services. So we will be selecting this one because we are going to perform the load balancing over the internet, right? And it will be classic HTTPS load balancer. So continue, name this load balancer LB web. Okay, and these are the few configurations that we have to do. So the backend configuration, we will be creating one backend configuration. So in this one, we'll name it LB web backend, and the protocol should be HTTP, right? And the instance group we will be selecting here, that is our web server, and the port number is 80. And here you will have this option for selecting the rate and the utilization. So it's like how much CPU you want to use, and this is the rate, how much request you want to send per second. So we will be using this rate. Port number is 80, right? And we'll be using this rate, and the maximum rate is we'll be keeping it as 100 per second per instance. Okay, capacity is 100, leave it as it is. CDN, and the health check we'll be using is HC Web 2. We have not configured the security, so we'll leave it as it is. Click the done here, and then after that you can click here create for creating your backend configuration. So backend is configured. Now let's go to the host path rules, and we don't have to do anything in here. We will not make any change here. The front end configuration will go and create. So LB web front end, the HTTP protocol will be there, and the tier that you want to select is the premium tier, and it is over the public internet, and leave it as it is. Click on done, and then review and finalize. You can check everything is in place, and then click on create. So it will also take some 2 minutes for configuring the web load balancer. Let's wait for 2 minutes. So finally our load balancer is configured. Let me click on this LB web. So how do we test our instances and this load balancer if that is working correctly? So we have this HTTP protocol and this IP address here. I will copy this IP address, and I will, let me close this, and I will open a new tab and try with the web address that I just copied. It is saying not found. The URL was not found. Let me refresh it. So wait for some time, it will work. It is giving the server error. Please try again in 30 seconds. So let's wait for some time, because once you create the load balancer, it takes some time at least for this load balancer to reflect. So now you can see here, hello from web server S2B6, right? Let me refresh it again. You can see that this time the request goes to the other host. Now again click on refreshing. You can see that the host name will change. That means that our request is being sent to both of our servers, right? So this is the way you configure your load balancer. And in this demo, we learned how to create the instance template, how to create the VM instances using the instance template, and how do we create the load balancing, how do we configure it, right? So that's it for this demo. Now let's move to the use cases of network services. So we discussed about this HTTP load balancing. It's a global load balancer for HTTP endpoints, and the use case will be CMS deployed in multi-region, right? TCP load balancing we discussed, and this is for regional load balancing of TCP and UDP endpoints. So typically this is used for gaming backend services. Then this VPC is the virtual private cloud that is used for private network within GCP. And the use case is to deploy GCVMs that are not exposed to public internet. And we also discussed about this cloud interconnect, where we have any on-prem application that needs to be kept on on-prem only, but it has to be used in combination with the cloud apps. So in that cases we have to use this cloud interconnect, so dedicated network to extend local data centers, right? Access cloud resources from local application with a low latency. That's the use case. Then we also discussed about this Cloud VPN, where if you want more cheaper options for extending your local data center, in that kind of scenarios, you can use this Cloud VPN, and that is secure access to GCP resources through public internet. And we also discussed about this peering, wherein you can directly access the cloud resources with reduced egress fee. So this is the more cheaper option. Wherever you have a one-way communication, in that kind of scenarios you can use this peering. All right, so these are the use cases, and that's it for this section here. If you have any doubts, you can directly write it in the comment section. And if you have not subscribed to the channel yet, I request you to please go and subscribe, because we keep on posting videos like this and it will be very much helpful in your career. So thanks for watching. See you in the next section.